Okay, so we're going to do a bit of a video here on frequency distributions. Okay, so a frequency distribution is basically a table that shows how data is broken down amongst several categories. The categories can be both quantitative or qualitative, but typically we tend to lean into the quantitative here a bit just because they make more interesting tables. So let's say I have a table of populations or a sample's IQ scores, and I have their frequency. And I break this into classes. So I have a 50 to 69 class. I have a 70 to 89 class. I have a 90 to 109 class. I have a 110 to 129 class. And I have a 130 to 149 class. And I have a frequency here of 2, 33, 35, 7, and 1. Okay, so lots of IQ scores here between 70 and 109, fewer as we're going out. Okay. So what we have here are a lot of information. I mean, we've taken a data set, we've summarized it using a table. Now, let's talk about some of the features of this table. We have things that are called lower class limits. And lower class limits are the smallest numbers that appear to belong to certain classes. Okay, so the lower class limits here are 50, 70, 90, 110, 130. Okay, so those are what we would refer to as the lower class limits. The upper class limits are the other side, the 69, the 89, the 109, the 129, and the 149. So those are the upper class limits. Now, there's a little bit of a distortion here, okay, because, see, it's possible, like when measuring something like IQ, I might come up with something between 69 and 70. So what's going on here is there is some rounding, okay? And we have things that are called class boundaries, which are the numbers kind of like halfway between the classes. So below this class, the class boundary is 49.5. Then we have 69.5, 89.5, 109.5, 129.5, and then finally 149.5. These are what we're going to refer to as the class boundaries. So these are numbers that actually say which class to put them in. So if somebody had 69.4, I'm putting them here. If someone had 69.6, I'm putting them here. So there's like just following the normal rounding rules. Now note, you also, like if it lies on the class boundary, if it's at 49.5, it goes into the next higher one. Okay? So if it's exactly at 89.5, it's going to go into the next higher one. So if it's exactly on the class boundary, you go up, not down. There's another useful number sometimes that's seen in here, which are called the class midpoints. The midpoint of this class is 59.5. The midpoint of this class is 79.5. The midpoint of this class is 99.5. Of this one, 119.5. and of this one, 139.5. These are used less frequently, but sometimes they're used to do some calculations. Basically, to get the midpoint, you take the lower class limit, the upper class limit, add them, 50 plus 69, and divide by 2. It's the average of the lower and upper class limit gets you the class midpoint. Okay, so this is a pretty basic frequency distribution table. I did say that not all frequency distribution tables are numeric. You get far less information when they're not, but let's take a look at one that isn't. So let's build a frequency distribution that could be made for qualitative data. So let's say we have the East Haven, I think that's in Connecticut, traffic tickets. Okay, so this might be the traffic tickets issued by the police department in East Haven. Let's say it's Connecticut over a certain period of time. And we're going to make a heading here. We're going to have a heading by race and by frequency. Okay, so race is definitely a piece of qualitative and not quantitative data. It's something that you can't easily put a number to. It's not something that's counted or measured. So let's make a list of identified races on these tickets. White was one of the races that was used on tickets. Black was another race that was used on the tickets. Asian was a race that was used in reporting. Hispanic and they had it as white and Hispanic, which is interesting to me that that's a distinction that we commonly make. So I'm assuming that this group, Hispanic, would be non-white Hispanic as opposed to white and Hispanic. And then there were some tickets that had no indication of race. So either the person did not self-identify or the reporting officer did not identify the race of the person. Race is a funky thing when it gets reported. Okay, so 329 white people got tickets in East Haven during this time period. 15 black people got tickets, 0 Asian people, 18 people who were identified as what we're assuming to be Hispanic, not white, 4 were Hispanic and white, and 5 had no race identified on the ticket. Okay, so this gives me some information. It tells me, how the spread was over the group. I'm sure it leads you to lots of questions, but it's definitely a useful form of summarizing data here. A frequency distribution ultimately is a way to summarize data. It breaks either the population or the sample into classes. Oftentimes those are numeric, sometimes they are not. So in the first example here, the classes were numeric classes. Here they're by race, which is not a numeric reality. Frequency distributions can be both qualitative and quantitative. Okay, so there you go.